It's really a pleasure today as part of our April Ethos workshops to co-develop, if you like, this seminar with an expert in the field on sustainability. So Professor Sean Smith, he is a chair of future construction within the School of Engineering here at the University of Edinburgh. And he is also the director of the Centre for Future Infrastructure in the EFI, the Edinburgh Futures Institute. His son is a man of many talents, and he is also the director of the newly funded UKRI Centre for Net Zero High Density Buildings. So we couldn't think of anyone else better, like to talk to us about sustainability and the challenges that sustainability brings. So this effectively presentation will cover a range of different aspects on sustainability. With sustainability at the heart, it will discuss the different sustainable approaches, carbon reductions, the golden thread, if you like, from the initial design concept to a full life cycle, and some of the insights that Sean has gained from other sectors, such as the construction and the infrastructure sector. So we're very much looking forward to Sean's presentation, and we will, if it's okay, we will allow Sean to deliver his seminar, and then we'll save all questions, until the end, where there will be enough time for everyone to ask their questions. So Sean, over to you. If you don't mind, please sharing your screen.
Thanks very much, Themis. So thanks for the introduction and to the AI Hubs for the invitation to speak. I'm just going to set this up, so hopefully you will all see this. I'll just reduce that, and hopefully that will come up. Can you see that just now?
Yeah, that's great. Thank you.
That's great. Super. Okay, well, good afternoon, everybody, on what is still a very sunny day in what has been incredible weather. Themis asked me to do this talk. I said, well, Themis, I'm not an expert in AI. And he said, that's not an issue, Sean. He said, we're interested about infrastructure. We're interested about the aspects that AI relates to and where it's going. So with that in mind and the hat of sustainability, I'd like to take it from the kind of design right through the process, that golden thread, and how we think about everything from that idea inception to the end of life of a product or a system or even a building or infrastructure. Just a bit about ourselves. We're the Centre for Future Infrastructure. We're based in the Edinburgh Futures Institute. And of course, the EFI's role, like many institutions across the UK, is to look at many of the world's major future issues and challenges and try to solve those. And specifically with EFI, we have a strong focus on the interdisciplinary approaches, how we can link the Futures Institute across our 22 schools and 100+ research centres and institutes. Our institute here, the centre, covers a whole range of areas. But of course, with infrastructure, huge elements around construction, but also right down to product and product design and thinking about circular economy from that very start, that very inception. So I have to say it's a wonderful world to work in. It's very challenging also, and range of policies and other aspects. So my thanks to the April Hub. This is a kind of joint presentation supported by April and also our new centre, the Centre for Net Zero High Density Buildings, which, as Themis mentioned, is funded by the UKRI. And we partner with 5 other institutions: Glasgow, Strathclyde, Napier and University of West of Scotland, amongst other organisations such as our National Innovation Centre here called BEST, Built Environment Smart Transformation. And that focus is really to take some of the real challenges of dense streetscapes, dense buildings, and also many historic buildings that are in our towns and cities, and how can we convert them into that net zero delivery, but also take the occupants and buildings with us. Now, AI offers obviously a whole range of significant benefits, and I'm not here to tell you all the wonderful things it does in sustainability across the different sectors and its application, but you'll be aware of these: the optimization of operations, timescales, the productivity that can be gleaned from AI and the AI work that you're all doing, those sort of inserts and opportunities around decision processes, new knowledge, accelerated findings, the common language that AI also offers globally, and that global reach. So these are the things all we know about what AI can do, and many other things. But one of the things I'd like to focus on very strongly today is where are we going in terms of the infrastructure for AI, starting at the very, very large scale in terms of the buildings, in terms of their cooling, their waste heat, the energy demands that these are going to require? And are we really thinking about design for deconstruction, even in these huge data centers that are currently being built or have been built? And certainly when we look to the future, design for disassembly also occurs in terms of fabrication of components, assemblies are going to smaller scale, and even down to the process of micro components. And again, design for disassembly comes up. So really, there is a golden thread that needs to run all the way through from the very largest of infrastructures that we build down to the very smallest nano micro level that you're all working on. So what I want to do today, if I may, is it's very important to look at the context of the current environment and the challenges which are coming ahead, and why sustainability, as you'll know, has been rising up the rankings in terms of so many features in policy and government and industry. But also, apart from climate change, there are many other issues going on too, which we need to address. So the next 20 years, the world's going to spend roughly about 100 trillion on buildings, transport and infrastructure. And the likelihood is it will well be beyond $100 trillion when we look at some of the investments which are also coming down the line vis-a-vis the new data centers that are being planned. The built environment itself, unfortunately, is responsible for 40% of the global carbon emissions, 30% of the global energy use, and consumes, sadly, nearly 50% of the world's natural resources. So in everything we do, particularly for data centers to support AI and any other infrastructure that's interlinking with it, or how AI can support more sustainable approaches for our built environment, become incredibly, incredibly important. So let's park climate change, which I know is difficult to do, but beyond that, the other thing that's coming over the next 75 years is global population increase. And with that, that's about 3.5 billion increase in population. That's a medium trajectory increase, by the way, from the United Nations. It's not the highest trajectory, but we'll need to build about 1.2 billion homes. And because people are living longer, we have higher divorce rates, we have more singular households for much longer. And plus, because people are living longer, we'll also need to ensure that we have 800 million new homes for the existing population, because we don't have that cycle of people leaving their properties, etc., as we used to do 50, 40, 60 years ago. So as a result, we actually need to build about 2 billion homes in the next 75 to 80 years. Huge, huge demand on material resources. So let's just give that context. Taking Europe on the left there, we have 29 countries, about 320 million homes. Imagine all the schools and infrastructure that's in those streetscapes you see in each of these towns and cities across Europe. And then you think, well, if I have to build 2 billion homes and all the infrastructure to support what's coming down the line over the next 75 years, that's equivalent to building about 6.25 Europes in 75 years in scale across the world. And when we also consider that it took Europe a good 250 years to build what it has now, but we have to do all of this 6.25 times around the world in the next 75, 80 years. And if you don't want to think about Europe, you want to as a multiplier of the USA, it's rebuilding the whole of the USA 9 times in 75 years. So unfortunately, when we look at net zero, we are definitively globally not on track. And this is important when we look at where AI is going and the infrastructure that will be required for it. And despite some attempts to improve what we're doing with our zero carbon building stock, for example, we're still a long way off and much, much to do. And the clock is ticking. And when we look effectively at how we could potentially get there, we look at different pathways to goals, it also seems quite an immeasurable task to achieve this. And hence the significance of so much of what's coming in the AI sector and the supporting infrastructure plays a critical role. But enough of these graphs, they're too depressing sometimes to look at, but they are a challenge to us, and they set the scene for the things that we're going to have to do in all of our thinking, no matter what it is. In addition to that, when we look at the global floor area of buildings and energy requirements, and this is the International Energy Agency, they looked at net zero emissions for 2050 scenarios. As we decrease those emissions across the sector, you can see also the red dots represent actually the increase in billions of square meters of floor area of buildings that we will be building over that 30-year period. So a staggering amount of activity and work required, all calling on resources, all requiring energy in some shape or form, whether it's for warmth or coolth, which we'll come to shortly. But nevertheless, when we think about sustainability in anything we are doing, when you step back and look at the huge big picture around the world, it is a significant challenge. But we academics and researchers in industry, we like challenges. So if you've not seen this before, this is very commonly the process that we use around the construction sector when we're looking at products and construction stage, when something's in operational use, when we approach its end of life, and then we look at the benefits beyond the building life cycle or the asset life cycle, its reuse, its recovery, etc. And one thing that's fundamentally important here is that something is not shown in this typical journey, maybe because we just take it for granted. But the most important thing that happens here when we look at carbon emissions on any plan of stage of product or construction is what happens right at stage zero. What happens in that design? Because that dictates so much of what's to come, whether it's an individual product, micro nano component, right through to large scale infrastructure. And therefore we need to give that much more attention. And even when we design an asset, whether a product be, or could it be a large infrastructure or building, it doesn't matter that we just consider it at that point when it leaves the factory. We have to consider its life journey, how we will replace it, what's the maintenance, how often. Are we designing the components in our circuit boards, for example, that they can be easily replaced and we can design for deconstruction and reuse all of those materials and those components? In construction, we've had to do this for a significant number of years. We've got a lot better at it. Okay, we're dealing with very large items, but at the same time, we've also designed in many attributes within products which allows us to reuse and recycle more easily. And this is because the whole sector really was, back in about 2003, 2006, hurled into, as it were, their responsibility of what they need to start doing for sustainability. So when you're looking at sectors, probably the construction sector has been at this for the longest period of time in testing and developing. It's still ongoing, which forms new R&D, it supports new innovation. But nevertheless, the challenge is still there. And when we look at global CO2 and we look at the CO2 equivalents and our circularity, we often focus on the operational carbon, understandably, because operational carbon is the predominance of how we look at net zero. But it's that embodied carbon in the materials, that growing importance. And where will those raw materials come from that we need, and can we recycle them sufficiently? And are we embedding design for deconstruction, otherwise known as design for disassembly, in the future of what we're doing now? So are we thinking about our future generations and how we will deconstruct and reuse these materials? And how do we incentivize the recovery and reuse? But importantly, no matter the sector, be holistic in all our thinking. This is quite typical of the circular economy, sort of circularity gap reports. This is the one for Scotland. And what's very interesting in it at that time, but this was just about 3 years ago when this was published, of course, data centers didn't feature. Yes, it covers all sorts of things like millions of tons of energy and food and agriculture and forestry, and where construction plays a part. But it would be interesting in 10 years' time if we looked, for example, at the UK or the eastern seaboard of the USA, where some of the big data centers are going in, and we start to look at where was the energy and material consumption input, where was the export, where was that going to? But they're very, very useful diagrams to give an idea of the flows of materials and our interlinks. Just one final thing. Construction is often blasted as being terrible for, its waste. And on the left-hand side, you can see in the pie chart, we've got household waste. So this is the waste streams, for example, that are going to landfills. About 21% in Scotland of our landfill is from household waste, way down from what it used to be, but nevertheless, there's still some. 28.3% is commercial industrial, but just over 50% is construction and demolition. And everybody, sighs and just gets very desperate about the situation. But actually, when you break the data down, and this is where data becomes important, is actually 73% of that 50.7 is in fact soils. Because as we move soils across construction sites, as we regain brownfield sites and we put and reuse sites for new housing or other things, which was industrial land, we need to cover it with soil. And so when you dig down into the statistics, that soil has to actually be included within landfill, which seems rather silly, but nevertheless we have to. And the 21% is in mineral waste, so that's particularly aggregates and stone. So between them, 94% is actually materials we're moving around anyway. That's not to say we take our foot off the gas, but when we're looking at waste streams and we look to the future, particularly the electronic sector and the whole AI sector of where that's going, then it's very important to look at data. And one very important document you must read, if you've not read it already, is IWA 42. This is the Net Zero Guidelines. This will become an ISO. It's an IWA at the moment, International Working Agreement. It was led by the British Standards on behalf of the ISO committee to develop a common net zero guidelines. And it's tremendous in terms of the direction and pathway, and that will move from an IWA to an ISO. So please have a look at that if you're working in this field. It's very important. The number 42 I thought was rather interesting. They chose that number, and I did challenge the British Standards. Why did you choose 42? They didn't give me a reason, but I wondered if it was anything to do with the the meaning of life in the universe, if you've seen The Hitchhiker's Guide, which the answer was number 42. Anyway, we have a global growth for net zero electrification across the planet as we remove our fossil fuels. And then, well, along came AI data centers. And when we look at some of the reports, some of them are here. I've put links to all of the reports, and I think we're going to be able to share the slides after today. So please access all this data that's there from these reports. For those that have seen the IEA report on energy and AI, it's fascinating when you look at the data center electricity consumption and household equivalents of some of the largest data centers that are being planned. But the great upside of data centers and where we're going to need to put them is they're very close to urban centers. And that creates a number of benefits. Of course, it's had a lot of headlines in different areas, but specifically around electricity and energy and how much we will have to use. So I'll let you read these at your own discretion. But more recently, there was a study done by Agreco, which looked at the construction managers who are currently building in the UK and Ireland future and current data centres. And what was very significant there was the concerns from construction managers and the real push on reducing the environmental impact from them. We've seen an increase in the utilisation and potential future greater use of battery energy storage over the past 2 years as utilised into data centres and data centre plans. And also another issue coming up is noise and how to address some of those noise issues which are appearing in environmental impact assessment reports for future data centres to support AI. When we look at the building sectors across the globe and we look at electricity demand in itself, you can see the annual change in electricity consumption by sector for buildings between 2023 and 2024 has been shooting up, much more than industry or transport. This electrification as we switch from fossil fuels into more electric use, but specifically, much of this has been driven by the power and requirements of new data centers and also some of the severe heat waves in China and India. Honeywell produced a very useful short paper which looked at where we'll be by 2030. And they forecast about 10% of global electricity demand will be taken up by the design and use of data centers. And that is a huge proportion of electrical power that's going to be taken by them and used by them. So it's incredibly important we get this right. And you've seen all these diagrams before, I'm sure, about the footprints of different search engines and search requests, the energy utilization required. I won't need to go into those, but anything we can do to reduce that would be absolutely fantastic in terms of reducing that energy consumption and being more sustainable. But we know that AI is also being incredibly useful across the construction sector already. We're using it in automated design and modeling, improving fabrication, enhancing that collaboration, and also in predictive maintenance. And ironically, the very data centers that we're building now, a lot of them are actually using AI in their design to help maximize and optimize the approach. So some real benefits coming there in how we approach the sustainable agenda using AI at the design stage. One of the biggest features of AI data centers is the heat and the waste heat. And there's a number of things we can do with that. Some of these you'll be aware of already. We can plug and play that waste heat into what we call networks, such as heat networks for buildings or heat networks for housing. We can also do direct supply, such as direct to swimming pools, velodromes, or directly into industrial processes. And even better, we could optimize that heat supply and the building operations, which can be AI-based. So it's a win-win on two fronts. And we're going to come back a bit more to this later. Of course, there's a double burden when we look at what's happening with AI, and particularly the data centers with the amount of water usage that's also required. So we have a dual challenge across two fronts, energy and water. Now we can lean into that change. We can change the liquid cooling technologies which are utilized. We can use air-cooled systems where possible. And if possible, we could use the existing water-based cooling systems, but by using the water that's recycled or reducing the amount of water that evaporates. But nevertheless, in every dimension that we look at an AI-supported data center that supports AI, we have to look across the board at all the various measures that we could undertake. And when you think about some of the water shortages which are going on now across the globe, and also the requirements and the demand on water, particularly drinking water in various countries and various developed countries, and the plan that we're actually going to build 40% more reservoirs than we currently have now to put more water into storage, but also to use it for hydropower as we use more renewable energy. The pull and push on water from different sectors will be significant. When we look at that double sort of push on water and electricity demand, a very good report that was done here in Responsible AI by the Royal Academy of Engineering, IET and others. And now you can see what's the kind of forecast going forward when we look at the financial years, total water consumption across all operations, but also when we look at the future up to 2050 of that potential spread of projected electricity demand of UK data centres. Huge numbers we're talking about there, up to potentially 35 terawatt hours. Significant demands. So how could we utilise it better, particularly that waste heat? Well, Dublin was one of the first to do this back in 2018 in an area called Tallaght, where the Amazon data centre, which is shown here in orange, was the source of the waste heat. And planning over the lifetime of the scheme and the surrounding developments, they could actually support 2,000 to 3,000 apartments just served on a district heating scheme from the waste heat coming from that Amazon data centre. And the same organisation as Fortum, who partnered with Microsoft, the Finnish energy company that maintains the Tallaght system, announced they were developing perhaps the most ambitious yet, where they would deliver heat to 100,000 Helsinki residents, saving 400,000 tonnes of CO2 every year by extracting that waste heat and feeding into local housing, which is tremendous. But it's not just that, and I'm not saying we have to build swimming pools and build velodromes right next to data centres, but if you had a velodrome next door, that's the place to put your data centre. Or if there's the opportunity with swimming pools, because that waste heat can be considerably used in both venues. For velodromes, for example, we need an optimum temperature of roughly 27 to 28 degrees. That track requires a constant temperature, and therefore the potential to use industrial or waste heat from the likes of data center buildings gives a tremendous opportunity for, if it's local authorities and municipalities, to lower their energy costs in the operations of velodromes, but also in terms of when we look at swimming pools. And one of the things is we kind of forget, sometimes we don't need the waste heat from an AI data center, for example, to get to the exact temperature we need for the swimming pool. What we're actually looking for is the early increase in temperature. That pre-warming, which is done by the waste heat, is where the biggest benefit is gained by using that waste heat to reduce energy costs and energy utilization from elsewhere. So, and that sheer volume of water which can be affected by that waste heat is just fantastic. So we talked about warmth and coolth briefly. So the world, when we look at net zero and global futures and needs, about 30% of the world needs warmth, but 70% of the world is going to need coolth. And I kind of describe it as the catch-22, which of course contradiction, dilemma, paradox, quagmire, like sitting on a powder keg, having to address both camps, or in some cases one camp over another, depending on which country you're in, the geography and the environmental ambience that you have to deal with. In the recent periods, certainly in up to 2024, the Northern Hemisphere has received some of its hottest summers. Over the past 12 months, the global average temperature has risen, and China has also had major issues, as has Thailand, India, Saudi Arabia, and Mexico. And you might say, well, what's this got to do with us? Well, the issue is that all of these major countries are going to require accelerated amounts of cooling, which will pull demand on electricity. And in which case, if we're pulling that demand on the electricity, can we still have sufficient electricity for the planned data centers to support the AI growth around the world that we all thought we would have? And particularly for India, which is very, very tough. 8 of the 9 hottest parts of the world currently are in India, with the specific heat waves that they've had over the last 2 years. So in that context, when we then start to compare with Europe and we look at trends of where we're going in 2050, we look at the air conditioning demand and the amount of electricity that will be required for that, we now start to think about where would you be positioning most of your major infrastructure for data centers if 1, you have sufficient power and electricity supply, 2, is it renewable, 3, can it be co-located in a sustainable way with other uses to extract that waste heat? And particularly in hot countries, for example, where they require cools, can we actually extract the waste heat and put that into industrial processes? And so you'll tend to find that in warmer and hotter climates, the waste heat from AI-supported data centers will, in fact, probably go into industrial process as opposed to other housing, etc., which you see in the Northern Hemisphere where it's cooler. And just to give you an idea of India at the moment, the last 4 years of trends in electricity demand, they are significant. And the average daily electricity consumption has been going up consistently year on year as people require more air conditioning and cooling. And then when we look at the capacity of their installed data capacity and the electricity generation mix, there's another pressure. Just looking at that one continent alone, that one area, one country of India, you look at the pressures that they will have as they, 1, try to push in more renewables and also deliver the expansion. When you've got a country that's going to overtake China in the next couple of years by population, such as India, the opportunity of data centers, that growth is significant, but only if the infrastructure can support it. When we look at the wafer production for the use in AI and other processes, the micro nanochips, then it's interesting to look at the preparations, the sort of the megawatt hours that are used per wafer, which are quite significant. And of course, as we go down in size of the wafer thickness, for example, so we use more and more energy. So in essence, we are by ourselves, through our own success, potentially in the operational support side of where AI is going in the infrastructure, creating fantastic new innovations in terms of reduced thickness and operations, but actually we're driving up also the energy utilization which is required. And then when we look across all data centers or enterprise or co-location and service provider or hyperscales, then we look at the role of servers, storage, network, cooling, and other infrastructure. You can see that kind of breakdown. Again, this was in the Energy and AI report from the IEA. Really useful. So finally, I wanted to finish off on a few things about electronic waste. We are seeing electronic waste rising 5 times faster than the documented e-waste for recycling. So that means that we really are not succeeding on e-waste recycling. And at a record 62 million tons of e-waste in 2022, that's up 82% from 2010. And we're on track to rise to another 32% to 82 million tons in 2030. So in a sense, we don't want to make the mistakes of the past. As we're designing for the future, from the nano to the macro scale, to support AI and everything that it will need in its infrastructure, let's not make the mistakes of the past. And let's ensure we design for deconstruction, and it's paramount from the inception. There's an excellent paper here which was in Nature Computational Science, which was looking at the e-waste streams, but how under different future GAI, that's generative artificial intelligence, if we could implement circular economy strategies along the GA value chain from the design, from the inception right through, then there could be huge savings in that e-waste. And therefore, that kind of underscores that importance of proactive e-waste management, and specifically at the design stage. So I know it's been a run through of many things, but I would leave you with these few words. The AI sector has immense scope through its applications to deliver so many benefits. We're seeing them in construction sector and infrastructure right now, which is tremendous. And thanks to everyone who's doing that, it's brilliant. But the infrastructure to support AI and all the emissions, energy utilization, water utilization that's required is a major concern. If we can make those early interventions at the design stage on any aspects of AI, then we can maximize the sustainability. And this is not a nice to have, it is an imperative. And whether through heating or cooling or other benefits of the AI infrastructure, there's a tremendous way to engage with local communities where the infrastructure will be placed and support those communities and societies around them. So thank you very much for your time. And I think we've got some time for questions. Thank you.
Thank you very much, Sean. That was exactly kind of what we were hoping to get from this, as a brilliant kind of summary of all the challenges there that AI brings. Do we have any questions? I'd like to open kind of the floor for any questions from the audience. If you do, please raise your hand. It would be good if you could switch on your camera and your mic. And I'll probably start whilst we give like time for people to reflect on all these wonderful things that you told us. So where do we in the end? The thing that really stuck in my head was that we need to build something like 6.5 times Europe's going forward. So where do we build those houses, and where do we build our data centers to make sure that like the overall environmental footprint is working to our benefit?
Yeah, good question. Well, what we'll try and do is most cities are going to rebuild on their existing, what we call brownfield, where there's already been industrial or pre-applications there before. I think what's really interesting is we optimize transport routes for 20-minute neighborhoods. Again, some of that is AI developed. There's an opportunity to how AI can play a role in the design and optimization of designs, layouts, plannings, and meeting community needs, because it's multifactorial. And that's what AI is very good at, is that opportunity with multi-factors to compare and contrast different ways and approaches. Where we'll build them is a very good point. Certainly we'll be going vertical, because we're going to need to utilize as much land as we currently have, or have it ready for future food infrastructures and to support future food infrastructures, given what's going on. But there have been people to come and see us 2 years ago who want to start building floating cities. So don't expect it all to be on land. I think quite a lot of it could be on water soon.
That could be great fun. But certainly there must be, it sounds like an oxymoron on one side that, AI is really helping with the productivity. And that's exactly what we see in the April Hub, how it can really help engineers to be super efficient, give them superpowers in a way, right? So it reduces overall the person sort of time that, you need to put into designing circuits. So it certainly will have loads of savings that we're getting from AI, but at the same time we're painting the picture that the AI comes at a significant kind of demand like for energy and for the environment. Where are we? Is it just one way, or is there a hope to sort of gain some balance across?
I think if I'm very pessimistic, I think it'd be difficult to create a balance. I think there's so much of it coming. It's how much we can help design or improve the designs at that early design stage before too much has gone down the road. And if that's done correctly and done appropriately, and you have the municipal or local authorities involved with that, about that infrastructure location, which many of them are, and they'll integrate it and discuss with communities. Many cities and towns are going to expand their heat networks. And these are the pipe systems. You saw the photograph there of a typical pipe system of all the pipes for a heat network. that's the very thing you want to tap into. So what we are seeing, and we've seen it at the University of Edinburgh, is we are building either new buildings or refurbishing buildings where we're putting in that heat network connector tap, as it were, on the outside. You can't see it, it's under the ground, but it's there for a plug and play. And there's the opportunity, if we have some of the new, fantastic new computing centre facilities that we're planning for up here near Edinburgh, then again, there's a fantastic opportunity that would support, local housing, existing housing, and particularly social affordable housing that's nearby where people struggle to pay their bills. So many benefits, but yes, at a cost.
I think there is already some expertise there, especially locally. I mean, we've seen with EPCC, the parallel scale compute capability, which is the largest supercompute capability running at the moment in the UK, hosted in the University of Edinburgh premises, that the story that many people don't know is that the heat created from this supercompute capability, it heats up about 5,000 local houses. So that's a very interesting story. I see that we've got a raised hand, so pass on to our colleague to come live and ask his question. Cosma?
Hi there. Thank you very much for the amazing presentation, Professor. I am currently a student at Trinity College Dublin, and I have just completed my exams on a module very similar to what you have talked about today. And I would really like to ask, if we do develop district heating for houses and pools and velodromes, as you've mentioned, what happens? Is there a plan, a backup plan, once these AI data centers have been decommissioned? What happens to the heating plants and the renewable energy? Do we revert back to fossil fuels and increasing the carbon footprint?
That's a very good question. So I think in most cases, what will happen is, let's say you build a data center now, and that heat is generating through the heat networks, local housing. And let's say in 20 years' time, you no longer require that data center because AI has got so good. It's now this size instead of a whole building. No pressure, folks. I know you've got to design that. But what you could then do is you could then bring in industrial scale heat pumps, have it electric driven, renewable electricity, and then you're still pumping into the heat network itself using industrial scale. So people are planning for backups at the moment, that if some of the industrial waste heat or business waste heat is removed, there is the opportunity to replace with these industrial level type heat pumps as a replacement to source energy onto the network for the heat.
All right, thank you very much.
Are there any other questions? Yes, Ben.
Well, hi, Sean. Thank you very much for the wonderful presentation. Really inspiring, actually. There's definitely a lot of commonality with what we're trying to do here. My question is maybe a sort of blue sky thinking. When we're talking about recycling e-waste, I feel like the main challenge is the fact that these items are very distributed. When you have a building, everything's very centralized, and so it's easy to manage those things. In your experience, how do you incentivize users and consumers of these kind of technologies to actually participate in the circular economy? Yeah, so that.
No, that's a very good question. And I think if one area I'm really interested just now is and I'll name them, but there are others. So it's a bit like saying there's Sky TV, but there's BBC and others. But anyway, there's a company called Danube Robotics, and they are looking at the elements of using robotics as part of that deconstruction. So if we can incentivize, if we can support people that if they have electronic waste, and let's say it's going into a large skip, when that skip arrives at this kind of depot, what you've then got, instead of someone trying to sort through it, you've now got robotics, which is then sorting through that waste and extracting, cutting, and then taking apart. And the opportunities of where robotics could go, which will probably require AI as well, some of the thinking considerations of it, is that could open a door. But how we must make a change is how we engage with the public. Our recycling currently is kind of plateaued. We're not doing much more recycling. And when it comes to electronic side of waste, it tends to go in a skip and it used to be sent to some other country around the world. We've seen greater value in the electronic waste. We just need to do a lot more and better recovery. So if we can design in now for our future components or future designs, how we'd recover that more easily, that would be great. Dealing with the existing waste streams, one, encouraging the public, and two, and when they're coming forward, they know that it's going to somewhere which actually can be handled in such a way with robotics or other things to extract it and disassemble it and reuse it as much as we can. But it is a big issue, Ben, I would agree. How do we engage the public so they understand that?
Mm. Wonderful. Thank you very much.
If I may pick up a little bit on that before passing on the next attendee to ask the question. I mean, one thing is obviously the recycling aspect, and you quite nicely touched on your presentation, Sean, about the energy demand and also the, like the resources that are needed, and the electronic waste. And I've heard recently for another talk that we probably put down the drain about two glasses of water every time that we ask a question, like on a GPT, something like that. So how do we really, I mean, how much control do we have in changing our habits? I mean, we've done it before, or at least we attempted as a society to do it before, like with switching off our lights and being a lot more, kind of efficient in the energy use around our buildings and our housing. But I mean, how do we go about sort of changing our habits about the use of AI?
Well, that's very true. I think most people don't realize how much energy they're using. Maybe we need a little thing that appears in your window of how much energy you're using to do each task. Now, I can patent that right now, but we can all share the patent. But wouldn't it be great that every time you clicked on something, you can see how much energy is probably going to require energy to tell you that, of course. It's a bit like in houses, the utility companies, the power companies are very keen for you to have smart meters. You need a smart meter. But the smart meter didn't tell you what you needed. It was the in-home display. And then they might send you an in-home display, but what they didn't tell you was the running cost for an in-home display is about 50 to 80 pounds a year just to power it. So, yeah.
I see. And I will move on to Chandra Bahan, if that's okay.
Hi, Sean. It was really a great informative session, and I loved it.
Thank you.
I have a few things I will also have to say something about that. Like, for instance, this AI data center, they need to improve and go for the advancement. They need energy. So around the world, around the world, people are trying to be on the power, go in the front end. So just like, for instance, in the USA, they are trying to get the energy for the data centers to operate them. So what they're doing, they're just trying to get the cheap energy sources. And at the current time, the cheapest one they found, it is natural gas. And unfortunately, it is a fossil fuel. So how can we balance it out? Because as an AI driver, we have the responsibility that simultaneously we should improve the power or improve the efficiency for the AI data center or AI generation. And also simultaneously, we need to reduce down the carbon footprint, for instance. And we have many kind of things, like if we would like to have a green AI practices, let's say in our case, we can utilize the models, let's say ChatGPT model, that can reduce energy costs. For instance, inference and the training set, we can use the models, they can be less energy hungry. And also like, let's say training and inference, we do not go for this from the scratch. We can utilize the training and inference models that can be reused, just like a recycle, rather than going for the scratch and training and such. So these kind of two approaches, like simultaneously, should be there. So how can we make sure that we are doing both together rather than just going or focusing? And sometimes it is hidden, like carbon using the fossil fuels is still like a hidden. They don't tell what is going under. Only the news and people reported, those are very efficient to come that news into the picture. Otherwise, so how would you see that kind of things happening?
Well, I think you're right on the power side. Unless the client is wanting that green AI data center or green data center where they're stipulating things, then it falls on either the local authority or the municipality in their planning regime to enforce it. And of course, if power is cheaper, as you point out, through fossil fuels, then they'll go there. That said, once you've built it, at some point you may want to create your own self-generation if you can, because the way some prices will go in the future, and who knows, in 3 or 4 years' time, the political cycle may change, and suddenly the rest of USA starts to turn into California with some of the legislation of approaches. But what we can do as designers, as researchers, is help the pathway as much as we can, optimize the pathway, which you're all doing, which is great. And in that sense, if we educate more people about this, and more of the general public are aware and are concerned about where we're going. But it's great. We've seen here, certainly in our planning authorities, very green focus, what's happening. And some existing data centers that were planned in Europe were put on hold whilst they were relooking at greening it further. So they're still coming, but they're going to green more of that energy utilization that's going into it. But yeah, we do as much as we can where we can. Thanks for the question.
Great. I think we have one last question, which was typed into the chat, and if that's okay to take that soon. So question is from Hira Shafiki. What are the biggest challenges in retrofitting older buildings with smart energy infrastructure, and how can AI help to overcome them?
Good question. So in terms of the challenges of retrofitting our older buildings, one of the opportunities is around archetypes. So we have specific archetypes of buildings which are all built at different periods, and then how we improve the effectiveness of the, let's say, the envelope, whether it's for coolth or for warmth. That's an opportunity. The challenge around that is there will be a slight diversification on how many occupants are in the building, what's the heating source, what's the type of electric source that's coming in. And smart meters kind of said to everybody, hey, I've got a smart meter. But all it did was it just told the electricity companies what we're using. It didn't really give us the smart energy infrastructure that we needed. So could we adapt that more? And I think AI could help with that, how we integrate that, how people can see that and understand it. And a classic, if I may, I can just finish off with something. For many of you in the UK, you're probably all living in urban towns and cities, but in rural areas, for example, many people are not connected to the gas grid. And as a result, they have predominantly, if they're not oil-based heating, it's electric-based storage heating. And that storage heating requires a signal from what's known as the RTC, which is basically a message that's coming from the BBC, these what you call it, antenna poles, which sit along different farms and everything, which on top of hilltops, which transmit the signals when is the low tariff. Okay. Now, all of that's being switched off this June. You will have seen news about this. It was meant 2 years ago. It's been delayed. And so people are being told, because that's the way your low tariff kicks in and your storage heater knows what's happening, is through this radio controlled device. But that's all being switched off. And so they're saying we have to switch to smart meters. But we're not rolling out smart meters fast enough. And in rural areas, quite a lot of the smart meter technology, of course, is mobile connected. And therefore people can't always get a signal. So their bills are going up from £5 a day to £30 a day because they're going on the wrong tariff. So how could AI help some of that? Well, we know the postcodes, we know the house types, we know who's got the type of heaters. Could there be an AI mechanism that could be done to support the grid and the smart meters so that just happened in such a more sensible way? So anyway, we shall wait to see how that unfolds, but you're going to see a lot of that in the news over the next few weeks and months.
Well, thank you so much, Sean. I think that's a wonderful way to finish this, and it's been a super informative session, and we all really enjoyed it. Definitely gave us a lot of food for thought. So thank you so much. I'd just like to do a very virtual round of applause, if you like, for your contribution. I really enjoyed this, as I'm sure everyone else have. I would invite all the attendees to get on our website. I've put the link onto the chat. There is a number of other events that the April Hub is coordinating and is organizing. So please do stay in touch, sign up for our newsletters, and I'm sure there will be a lot more exciting other sort of similar sessions that you'll be able to follow. And of course, follow Sean's new center, because there is a lot of great things to expect there in terms of, you know, net zero kind of policies and information. So thank you so much, Son, again for this, and thanks for everyone for attending.